Alrighty, here we go. So let's try a few equations. We'll start with some basic equations and we'll increase the level of difficulty along the way. Okay. So question 1, got negative 2x is equal to 64. So in each of these, we want to solve for x. Question 2, got negative 5x minus 7 equals negative 15. Question 3, negative 2, 3x minus 4 equals negative 7. Question 4, I got negative 3, 4x minus 1 equals negative 2, 3x plus 4. Question 5, I've got 6x minus 3 over 4 equals to 9x minus 2 over 5. And in each case, we want to solve for x. We can write our final answer as a fraction. That would be fine. Without a calculator would be fine. Okay, give it a go. Let's see what you got for any of these over here. Okay, so in this first question over here, what we have is a negative 2 in front of a variable x, which means there's a hidden multiplication right over there. So we do the opposite and we divide instead of multiply by negative 2 on both sides of the equation because it's equal. So we want to keep it equal, but we want to get x alone. So we divide by negative 2 and we get x equals to 64 divided by negative 2 is negative 32. The next one, x is over here as a term on its own. Then I've got negative 7 and I've got negative 15. Now I want to keep this on the left-hand side of my equation. This over here, I want to move to the other side, or I want to remove it and then move it onto the other side. So to remove it or move it onto the other side, we would normally plus 7 on both sides, because by plussing 7, we'd remove it and we would then keep this alone on the left-hand side. So I'm going to plus 7 first on both sides. That simply gets brought down to negative 5x equals, and 15, negative 15 plus 7 is negative 8. I then divide by whatever's in front of x, very similar to this one, on both sides, giving me x equals to 8 over 5. For the next one, I need to multiply this bracket out. So negative 2 will multiply by each term inside the bracket. And negative 2 multiplied by 3x is going to get me negative 6x. And negative 2 multiplied by negative 4, and negative times a negative is a positive, and 2 times 4 is 8. This stays as is on the right-hand side of the equation. Now we're back here again. So what we do is we minus 8 to remove it, but we have to do it on both sides because it's an equation. So we're left with negative 6x, and negative 7 minus 8 is negative 15. We then divide by negative 6 on both sides, canceling out that gets me x equals to 15 over 6, because a negative divided by a negative is a positive, and that's how we ended up making that a positive as well. I'm just leaving my answer as a fraction. I could write this as a mixed number if I wanted to, or put it in a calculator and get it in decimal form. Okay. Next one, we have 2 of these brackets, so we're going to apply the multiplying on both sides. Multiply twice. Don't forget to multiply twice. Don't forget negatives. 2 negatives will make a positive, and a negative and a positive makes a negative. So carefully, negative 12x plus 3. Negative 3 times 4x is negative 12x. Negative 3 times negative 1 is positive 3. Negative 2 times 3 is negative 6x. And negative 2 times positive 4 is negative 8. Negative and positive becomes negative. Let's write that down quickly. So remember, negative times a negative is equal to a positive, and a negative multiplied by a positive in any order would become a negative. And obviously, positive times a positive stays positive, if you didn't know. Okay. Now, the next part here, I need to move this one across that side, and I need to move this one across this side because I want all x's on this side, and I want all numbers on this side. All right, so I want all numbers on this side and all x's on the other side. But in order to do that, I can move it and change it into positive 6x, for example. I can move this and change it into negative 3x. And that's called change signs and change signs. So change sides, change signs. So whenever you move a term over an equal sign, you change the sign into its opposite. So change signs into its opposite. So if it was plus, it becomes minus now on the other side. If it was minus, it becomes plus on the other side. Or you could go to this method here where you're plusing a number on both sides twice. Let's say we use this method and we stuck to it as well. Okay. So what I'm going to do here is remove negative 3. And over here, I am going to add 6x. And you can see, technically I've moved it and I've changed the sign. Technically I've moved it and I've changed the sign as well. Now negative 12 plus 6 is negative 6x. And negative 8 minus 3 is negative 11. So now I'm back to square one. Divide both sides by negative 6, and so x equals to 11 over 6. Done. All right. For the next one, I can cross multiply across like that. How does that make sense? I can multiply this by 5 and multiply this side by 5. In that way, this cancels out, and the 5 ends up multiplying by the top anyway. I can then multiply this by 4 and multiply this side by 4. And then the 4 cancels out, and I end up multiplying the top by 4 anyway. The denominators fall away. So to quicken that process, whenever you have a fraction equal to a fraction, that's what we have here, a fraction, and we've got another fraction with x in it. What we should be doing here is just simply cross multiplying. So 5 multiplies over here, 4 multiplies over here, and we can then introduce a bracket before we multiply it, just to make sure we don't make any errors. 5 times 6 gets me 30x, 5 times negative 3, negative 15. 4 times 9 gets me 36x, and 4 times negative 2 gets me negative 8. Now we're back to square one. This looks very similar to that. We want to get x's onto one side. We want to get all the numbers on the other side. So let's do the opposite of negative 15 and add 15 on both sides to remove it. Let's do the opposite of positive 36x and put minus 36x on both sides to remove the right hand side, x's. 30 minus 36 is negative 6x, and negative 8 plus 15 is equal to 7. We then divide by negative 6 on both sides, and so therefore x equals to negative 7 over 6. All right, writing our answers as fractions from here. All right, the next few equations, I'm going to try and include some fractions in the equations. Okay, so equations continued. All right, let's have a look at this one over here. The first one here, I've got x over 4 plus 4 over x, all right, equals to 5. Okay. And what you'll notice is this will end up as some kind of quadratic equation. And with the quadratic equation, whenever we want to find x, we use the quadratic formula in cases where it does not factorize. All right. In cases where it does factorize, for example, let's say I got a factorized form like this of an original question like this, then we can see straight away that x will equal 3, because if I put 3 in there, 3 minus 3 is 0. Or if I put 4 in here, 4 minus 4 is 0, and it fulfills this equation, in which case this would be a factorized form of that. Okay, so I can call this one part B, let's say. For this one here, I want to solve for x. I've got x in the numerator, x in the denominator, and no x value here. And I've got this formula that I want to use over here. Okay, is this going to factorize or not? Let's see if we can simplify this and try and solve for x. Get it into a quadratic form. So you want to get it all into this form over here, something that looks like that, but for this question. And then you want to try and factorize it. And if you can't, you're going to go with option B, which is using the quadratic formula to get to the solutions. All right, let's go through this one, and I will give you another one to try. Okay. The first thing I can see is that my denominators, this denominator is 1, so I can actually write down my lowest common denominator, which will be 4x. Now, using this denominator, what I can do is basically remove the denominators completely if I multiply the numerators by whatever I don't have in my denominator. So I'm going to multiply this by x, I'm going to multiply this by 4, and I'm going to multiply this one by 4x. And we're going to end up with x squared plus 16 equals 20x. Now, I've removed the denominator completely because of this. If I had 4x on both sides, I could simply multiply by 4x and remove it anyway. So whenever you have the same denominator on both sides of an equation, you don't really need it. So you can take it out. Now I'm going to move this across and make it into a negative 20, or I'm going to remove it by minusing 20x on both sides. I'm going to squeeze it in between these two terms and make the right-hand side equal to 0 so that it looks like that. Can I factorize this to get that? Let's check. 8 times 2 gets me 16, but 8 plus 2 is 10. Not going to get me to 20. 16 times 1 is 16. Max is 17. So I'm forced to use the quadratic formula, and I can see my a value is equal to 1, my b value is equal to negative 20, and my c value is equal to 16. So minus b is the formula. So minus 20 plus minus the square root of b squared, which is negative 20 squared, minus 4 times a times c, minus 4 times 1 times 16, all divided by 2 times 1 is what I'm getting at for this one. Now, I am going to simplify this over here, continuing. Negative and negative is positive, so that's positive 20 plus minus the square root of 400 minus 64 over 2. And I can put that on a calculator. I could also leave my answer in third form. All right, so we got to be careful and make sure we do what we need to. But 400 minus 64 is 336. So 20 plus minus the square root of 336 divided by 2 gives me two options for x over here. So I can have x equals to 20 plus the square root of 336 over 2, or I can have x equals to 20 minus the square root of 336 all over 2. And this is going to be 20 plus the square root of 336 divided by 2 comes to 19.17. And in the other instance, if I take 20 minus and then divide that by 2, comes to 0.835. Let's say to 3 significant figures. I could make this into 3 significant 19.2, let's say. It could become as well. Okay, so those are my 2 possible solutions for this. And what do you call this? This is called a quadratic equation. And why is it called a quadratic equation? Because it has the power 2 in it for x. Okay, let's try one of these. See if you can solve this using the quadratic formula. Type your answers in. There was some really good answers. Otherwise, here we go. This is going to be x over 2 plus 2 over x equals 2. Let's see what values of x you can get. You can round your answers to 3 significant figures as well. Okay. Alrighty. So let's have a look at this example now. And what I'm going to do is try and maybe use less steps in the space here. I'm going to get this into that form over here directly from there to there. This is going to become x squared plus 2x. So this is going to multiply by x. This is going to multiply by, 2x in each case, multiplied by 2. And this is going to be multiplying by 2x as well. Okay. If I multiply that carefully, x times x gets me x squared plus that's supposed to be 4. And this becomes 2x, which moves across and becomes minus 2x. So it becomes minus 2x plus 4 equals 0. All right. So I've done it all in one step. I've multiplied this by 2 and I've moved it. Okay. I've multiplied this by, 2x. And it's supposed to be negative 4x. Okay, maybe I should just use it in all the steps because that always helps to prevent errors. Here we go. This is going to be x squared plus 2 times 2, which is going to be 4. I'm going to multiply this by x. Writing this does help a lot because it gives you that ability to just make sure you don't make any errors. So x times x is x squared. 2 times 2 gets me 4. Remember, I'm dropping the denominator immediately. This is going to get me 4x. Then I rearrange it like that. But it looks like this one can factorize. So I don't have to use the quadratic formula. So it'll be x minus 2, x minus 2. And so therefore, x will equal 2 twice, which is the same thing. Right, so I can just write it once. So the final answer here, x equals to 2. Does that make sense? Yeah, I put 2 there, I put 2 there. 1 plus 1 is 2, so it works out. If I use the quadratic formula, it could have gotten me the same answer. And if I did do that, which was the objective of this, which is going to be a, b, and c, then I can see that a equals to 1, b equals to negative 4, and c equals to 4. So negative b plus minus the square root of b squared minus 4ac divided by 2a is going to get me negative minus minus 4, which is positive 4, plus minus the square root of b squared, which is going to get me 16, minus 4 times 1 times 4, which is 16. That ends up as 0 over 2 times 1, which is 2. So I end up with 4 divided by 2 alone, because this ends up as 0, getting me 2. Okay. All right, the next question, we want to solve for x, and they give you the quadratic straight up like this. They tell you that we got a question, we want to solve for x And we are told that we get negative 3x squared plus 7x minus 8 equals 0. And x can be found using the quadratic formula, minus b plus minus the square root of b squared minus 4ac over 2a. So we want to solve for x using the quadratic formula. All right, give it a try. Paper, it's an IGCSE extended past paper. But let's go through this one first. All right, so a is equal to negative 3, b is equal to 7, and c equals to negative 8. And so what we want to do here is substitute it in here carefully. So negative 7 is going to be b plus minus the square root of b squared. So 7 squared minus 4 times a, which is negative 3, times c, which is negative 8. All divided by 2 times a, which is negative 3. When we simplify this, we end up with negative 7 plus minus the square root of 49. 3 negatives becomes a negative. 4 times 3 is 12 times 8 is 96. And what you notice is that the inside of this ends up as a negative value. And so therefore, there are no solutions for this one. And this is an example where if you are square rooting a negative number, it cannot exist. Now, what does that mean? It means that this graph, which is going to be sad-shaped, is going to cut the y-axis at negative 8. So let's say negative 8 over here is going to turn and not reach the x-axis. So there's going to be this gap where it won't reach there. And it could be on either side, it could be this side as well. All right, but just a quick sketch to say that the x-axis, if I'm given the x-axis and there's no solutions, in this case here, it's a sad-shaped graph because a is less than 0. If a is greater than 0, it's a smiley face graph, and it will be there. Okay. So for this question, your focus is on area and perimeter and algebra, bringing in algebra components in there. Okay. All right, so this is just a random amount of questions, just cross multiplication. Okay, cross multiplication. So I'm going to multiply this across. This is going to become 2x plus 2, and this is going to become 15. And then the denominator is here. 15 minus 2 would become 13, so 2x equals 13, so x equals to 13 over 2. This one will make this 3x plus 9, and this will make that 8. And so 3x will equal 8 minus 9, which is negative 1. And so x will equal negative 1 over 3. This will become 4x, and 2 when we multiply it by 2. This will become 35 when we multiply it by 5. Then it becomes 33, and so 4x equals to 33. And so x equals to 33 over 4. All right, those random ones. Let's try another random one over here. Remember, we cross multiplying. 4 times 3 gets me 12x minus 16 equals 6x minus 3. And then subtract 6x on the left-hand side becomes 6x. Negative 16 plus on the right-hand side becomes negative 3 plus 16, which is 13. And so x equals 13 over 6. The next one we cross multiply here, it will become 9x minus 9 equals 8x plus 4. This becomes 8. This becomes x, and negative 9 plus 4 is 13. So x equals 13 for this one. All right, this one over here, we cross multiply, we get 24. But on this side, we end up with the quadratic. We're going to end up with 7x squared. We'll actually end up with x plus 3 times 7x minus 1, which would get me 7x squared. Plus x minus 21 is minus 20x. And 3 times negative 1 is negative 3. And so 7x squared minus 20 minus 20x minus 3 minus 24 is minus 27. And then we got to factorize this, or we got to use some kind of quadratic formula. At this point, we'd end up with negative 7x squared minus 20x minus 27, which we've now got to solve for. So we put that on a quadratic formula, and we make a equal to 7, b equal to negative 20, and c equals to negative 27. And that comes to the following. Okay, so let's just make sure we're doing this correctly. I'm going to go through it quickly over here. This is a bit more complicated than the others, right? So we got 2 times 12 equals x plus 3 times 7x minus 1. Let's check this out. This is 24. That's going to be 7x squared minus x plus 21 minus 3 becomes 7x squared. That's 21x. So it's going to be plus 20x. And minus 3 minus 24 is minus 27. So if a is equal to 7, b is equal to 20, and c is equal to minus 27, minus 20 plus minus the square root of b squared, which is 20 squared minus 4 times 7 times minus 27, all over 2 times 7, which is equal to 14 from there. Okay, so let's go to the next part. So we're going to have minus 20 plus first, let's say, square root of 20 squared minus 4 multiplied by 7 times negative 27 all over 14. And the answer would come to 1 if it's plus, and if it's minus, it'll come to negative 3.857, which is actually equal to negative 27 over 7, which means that this is actually quite factorizable. That means that I could factorize this into two brackets. The first bracket would be x minus 1, and the second bracket would be, if I make this equal to x, then it becomes 7x plus 27. So 7x plus 27, that is the factorized form of that, which can go straight there as well if I factorize it. Okay. So this question here is a word problem, and what we have is we have a triangle. So let's quickly draw a triangle. It's always good to draw stuff up. So let's draw a triangle, and we'll label it up. And let's draw a rectangle, and we'll label that as well. So the height of the triangle is h, and it says the height of the rectangle is h plus 2. And then we told that the length of the base of the triangle is x. So let's draw that in there. And we also told that the length of the rectangle is x plus 1, running right across. The area of the triangle is 11 centimeters squared. And we know that the area of this triangle will be base times height divided by 2, which will be h times x over 2. And the area of the triangle is 11. So we know this is 11 equals hx over 2. And it says the area of the rectangle is 39. Well, the area of a rectangle is given by length times width. The length is given as x plus 1, and the width is given as h plus 2. And the area is given as 39. So 39 will equal that. Let's say we leave it like that for now without any kind of changing it up. Okay. All right. So let's leave it like that for now. If I did have to multiply this in, I could end up with a quadratic. Okay. But let's say I didn't just yet. Not yet. All right. We're done with all of that. We've got our graphs. We've read all of this. We applied all this information. We put it in there as well. It says write down an expression now in terms of, okay, I'm not sure why that's flickering. Let's just have a look at that. Write down an expression in terms of x for the height of the rectangle. An expression in terms of x for the height of the rectangle. Okay, so what they want us to do here is they want to make h the subject of the formula. That's what they want us to do for a. So for a, they want us to rearrange this formula, making h on its own. I'm going to divide h plus 2 onto the left-hand side of the equation. I need to get h on its own, so I'm going to flip this side over, and I'm going to flip this side over as well. So this is going to become h plus 2 over 39 equals 1 over x plus 1. I'm now going to move the 39 across, and I'm going to get h plus 2 equals 39 over x plus 1. And I'm now going to subtract 2 from here. So h is going to end up as 39 over x plus 1 minus 2. And now h is the subject of the formula, and I'm done. Okay. Part B says, show that 2x squared minus 15x plus 22 equals 0. Well, I can rearrange this equation to make h the subject as well. It'll become 22 if I multiply that, and then divide it by x will make that equal to h as well. So which means h is equal to 22 over x, and h is equal to this, which means I can equate them into an equation. And so therefore I can take 22 over x, and I can make it equal to 39 over x plus 1 minus 2. Okay, so 39 over x plus 1 minus 2, where my common denominator is going to be x plus 1 times x. So I'd multiply this by x plus 1, I'd multiply this by x, and I'd multiply this by x times x plus 1. And so that'll become 22x plus 22 equals 39x minus 2x squared minus 2x. And when I move this across, I get 2x squared. And 39 minus 2 is 37. And 22 minus 37, 22 minus 37 will give me a negative 15, which is exactly what we want over there, right? And plus 22 just goes to the right. And so we're done with that. Okay. By factorizing it now, if I factorize it, I got to introduce brackets. I know the first two terms has to be x. And what if I choose 11 times 2 for this, right? If I choose 11 times 2, then I'm going to end up putting 11 maybe over here and 2 over here. All right, so that's 11 times 2. And then that'll be 4x, 11x, so both will be negative. And so therefore, x becomes 11 over 2, or x is equal to 2. So it can be 5.5 or 2 if we had to write it in there like that. All right, two possible heights. So therefore, maybe we need meters or centimeters. So let's not forget the units. Centimeters, because it's height over here. All right, and this answer here would be over there.